Hello everyone, it's Dr. C. What I would like to do in this video is talk about Lewis structures. So Gilbert Newton Lewis, G.N. Lewis, was a chemist, received his PhD at Harvard in either late 1800s, early 1900s. Shortly after getting his PhD, he was teaching a course, co-taught with his thesis advisor, and he introduced this idea of valence electrons being involved in bonding. And, you know, his thesis advisor didn't think much about it, didn't like it at all. And so Lewis probably, took a little bit longer to get his Lewis model together because of that. Finally, in 1916, he published a paper with this model. And it is, really the first early bonding model. And it works surprisingly well for how simple it is. Surprisingly well for how simple it is. So we're going to draw these for covalent molecules, molecular compounds, where electrons are shared. And so let's look at what the Lewis model is. First off, it's an electron pair model. So we're always going to be working with pairs of electrons, and it's based on the Octet Rule. So for most elements, we're going to try to satisfy the Octet Rule, 8 electrons around the atom. Okay? So, as it says in the next statement, atoms will share electrons. Again, we're looking for molecular compounds. Those are typically compounds composed of nonmetals. Oh, I don't think that fit on the screen. You get the idea, nonmetals. Okay? And so they're going to share electrons to achieve this octet. So here are the rules that I like to use for drawing these. The first one, count the dots. Okay? So we're going to represent electrons as dots in these structures. So we're going to count the dots. And the electrons that we're going to count are the outermost electrons, the valence electrons. Those are the ones that are going to be involved in bonding. Okay? The inner core electrons are not going to be involved in bonding, just the outer valence electrons. Okay, so on a lot of periodic tables, the valence electrons is the number at the top of the column. The new numbering scheme, where the column is just numbered 1 through 18, for the main group elements, which is what we're going to focus on, just use the last digit of that number. So if you're in group 13, that would be 3 valence electrons. Group 14, 4 valence, and so on. Okay, we're going to make a pretty picture. So we're going to arrange the atoms, in some way that looks nice. Okay, and typically the least electronegative atom goes in the center. More electronegative on the outside. Now, fluorine is the most electronegative element. It's always going to be on the outside. It's never going to be a central atom. Hydrogen's kind of the special case because it's in the first row, and in the first energy level we only have the 1s orbital, which can hold 2 electrons. So hydrogen doesn't follow an octet rule. It follows a duet rule. It can only have 2. So it has to be outside. Well, also what we call terminal. It has to be on the outside of the molecule. Okay, third step. We're going to draw a line between the atoms in this molecule. Okay, and this line represents a bond. Okay, and it's a 2-electron bond. It's going to count 2 of our dots, 2 of our electrons. So that is also, this line will be what we call a single bond. We'll talk about double bonds a little bit later in this video. All right, now we're going to try to satisfy the octet rule with our remaining electrons. We're not going to use all the electrons to make these bonds. We're going to have electrons left over. And we're going to satisfy the octet rule by putting dots on the outside atoms first. Okay? And we're going to put these in pairs. Okay? So these pairs of electrons around the atom, they're only going to be on that particular atom. They're not going to be shared. We call those lone pairs of electrons. All right, or sometimes, and we also call them unshared electrons. They're not shared, they're not bonding electrons. All right, so we want to make sure to get a total of 8 electrons around the outside atoms. Remember, the bond is going to count as 2, so we need to place 6 more. All right, and as we already talked about hydrogen, hydrogen can only have 2 electrons. Now, if we complete all the outside atoms and we still have extra electrons left, we're going to put those extra dots on that central atom. Okay, place the extra dots on the central atom. And sometimes, and we'll talk about when this can occur, sometimes the central atom will exceed the octet rule. But if something is going to exceed the octet rule, it needs to be the central atom. Okay? Now, sometimes we might end up placing all the electrons and the central atom might still end up short of an octet. And that's when we're going to have to make a multiple bond. By multiple bond, we mean potentially a double bond, maybe even a triple bond. It depends on how short that central atom is of electrons. Okay? And maybe we might have to make 2 double bonds depending on the molecule. All right, and so those are the rules. Okay? So keep those in mind as we're drawing the structures, and I will refer back to these as we go on. Okay? Now, some of the ones, not any in this video, but you might come across some molecules that are ions. And in those cases, if it's a negative ion, you're going to have to, so if you have a -1 ion, that negative charge is going to count as an extra electron when you count your valence electrons. Watch for that. And then at the end, we're going to put brackets around the molecule and indicate the charge. It's not a molecule, it's actually an ion. Sorry about that. And indicate the charge of that species. Okay? I'm going to do another video later on, a second video on Lewis structures that goes into some more detail. I'll do a charged species in that one. We're going to do all neutral ones in this one. So let's draw the correct Lewis structures for the following molecules. And let's start with nitrogen trifluoride, NF3. All right, so grab a periodic table, look at a periodic table. You'll find nitrogen is in group 5 or group 15, depending on how your table is labeled. So that's 5 valence electrons. Okay, so that's the first step. Count the dots. Count your valence electrons. 3 fluorines, each with 7 electrons. That gets us to 26 electrons. Now, this is an electron pair model, so you might want to count them as pairs. 13 pairs of electrons. All right, now we're going to make a pretty picture. That's step 2. Fluorine is the most electronegative element, so that's going to be on the outside. So nitrogen needs to go in the center, and just kind of arrange them around each other as you see fit. Usually we try to draw them somewhat symmetrically. Doesn't matter for the Lewis model. Okay, as long as, in the Lewis model, we're just worried about what types of bonds we have, single, double, triple, and we're worried about satisfying the octet rules. We're not worried about the shape or structure of the molecule. Now, step 3 was we're going to connect these with single bonds, okay, with a line. That represents 2 electrons each, so we've placed 6 electrons or 3 pairs. 6 electrons or 3 pairs. Now, next rule. Start to complete the octets with lone pairs, starting with the outer atoms first. Okay? So 3 lone pairs, 6 electrons, plus the 2 from the single bond, that's 8 for fluorine. Same thing for the bottom fluorine. Okay? 3 lone pairs, 6 electrons, plus the bond, that's 8. And you get the idea. Same thing for this fluorine here. All right. How many electrons have we placed, or how many pairs? All right. Now I'm going to count in pairs because I think it's just easier. So we're going to start here on the right, since that's where I started filling. 2, 4, 6, 8. Okay. And actually, let's do pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pairs. 24 electrons. We need to place 26. All right, so it says if you have any extra dots, put them in the middle. That's rule 5. Okay, so we put them in the middle on that central atom as a lone pair, and that's 26. So we've placed all our valence electrons. Have we satisfied the octet rule on everything? Well, we know we did on all the fluorines, and look at the nitrogen. 3 bonds, 2, 4, 6 for those 3 bonds, plus 2 for that lone pair. That's 8 electrons. Okay, so we did what we wanted to do. We used all the valence electrons The valence electrons are those involved in bonding, and we satisfy the octet rules for all the atoms. That is the correct Lewis structure for this molecule. Not so bad, huh? Let's practice another one. Let's go to xenon tetrafluoride. Xenon is a noble gas. It's in group 8 or group 18. That's 8 valence electrons. We have 4 fluorines. The fluorine is in group 7 or group 17, 7 valence electrons. We now have 36 electrons, or 18 pairs of electrons. Fluorine, the most electronegative, needs to be on the outside. I didn't leave myself enough room here, but you get the idea. Connect with single bonds. That takes care of 8 electrons or 4 pairs. Let's complete the octets. The next step. Okay, top fluorine's taken care of. Fluorine on the right. Okay, again, we complete the octets by placing unshared electrons, or what we call lone pairs of electrons, on the outer atoms first. That was our 4th rule. All right, let's see what we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pairs, 32 electrons. We've only placed 32. We have 4 more left to place. Where do they go? Now, let's go back up and look at Rule 5. If you have any extra dots, any extra electrons, in this case we have 4 extra electrons, you put them all in the middle. Okay? Even if you exceed the octet rule. Keep that in mind, because sometimes the central atom will exceed the octet rule. So I place 1 pair, 2 pairs, there's the 4 electrons. I've placed all 36. The octet rule is satisfied for the 4 fluorines. We have exceeded the octet rule on xenon. The central atom will exceed the octet rule at times. If you're going to exceed, make it the central atom. Now, when can the central atom exceed the octet rule? If it's in the 3rd row of the periodic table or below. Right? By the time we get to the 3rd row, the atom is big enough to hold these extra electrons. And we can think about, in this case for xenon, it's below, well below the 3rd. Let's see, argon, xenon, yeah, it's below the 3rd row. There are going to be potentially empty d orbitals that can hold these extra electrons. Okay, so you can think of it in terms of just simply size. This atom is big enough that we could put extra electrons around it. Or you can think of orbital-wise, yeah, there's some empty d orbitals these electrons can go into. All right, so sometimes the central atom will exceed the octet rule. It's okay if it's in the 3rd row of the table or below. All right, last one for this video. Again, I'll record another Lewis structure video that provides some more information about other types of molecules and ions. I'll do an ion. We'll talk about something called resonance. We'll even look at some molecules that don't get to 8 electrons. The central atom doesn't get to 8 electrons. It ends up short, electron deficient. All right, so the last one, carbon dioxide. So, carbon's in group 4 or group 14. So we count the dots. First rule, valence electrons. 2 oxygens. Oxygen's in group 6 or group 16. 6 valence electrons. That adds up to 16 or 8 pairs. All right. Fluorine's the most electronegative. Oxygen is right next to it. So oxygen turns out to be the 2nd most electronegative element. So carbon, the less electronegative, will go in the middle. Okay. We typically draw these as symmetrically as possible. Again, it doesn't matter for the Lewis model. We're going to look at another model later in a later video called Vesper, valence shell electron pair repulsion model, and that's where we're worried about the shape or structure of the molecule. All right, next rule, connect with a single bond. That takes care of 4 electrons or 2 pairs. Next rule, complete the octets on the outer atoms first. And we've completed the octets of the oxygens by placing lone pairs. Let's see how many electrons we've placed total. I'm going to count in pairs. 1, 2, 3, 4, 5, 6, 7, 8. We've placed all of our electrons. Are we done? We've placed all 16. Are we done? No, we're not done. This is not the best Lewis structure we can draw because carbon, as you can see there, is short of electrons. We only have 4 electrons around carbon. Those 2 single bonds are 2 electrons each, 4 electrons. Carbon is short of electrons. So let's scroll back up to Rule 6 very quickly and look at that again. If the central atom is short of an octet, okay, after placing all the electrons, if the central atom is short, we're going to have to make a multiple bond by removing a lone pair from one of the outside atoms. So let's try that. So what we're going to do is we are going to take 2 of these electrons, let's cross those out, and we're going to move them and make a double bond. Okay, so you see what I did there? I took the 2 electrons that were a lone pair, moved them up, and now I'm making them a bonding pair, shared electrons. So that's a double bond. That's a 4 electron bond. So each line there represents 2 electrons. All right, is that better? Yeah, we still have the same 16 electrons, but now carbon has 6 electrons around it. Still not an octet, but we're closer. What do you think we should do next? Yeah, let's take a pair of electrons from the other oxygen and move it up and make another double bond. How's that look? Yeah, that looks pretty good, right? So let's double check that we have 16 electrons. We didn't change anything, but counting the double bond, 1, 2, 3, 4. Other side, 1, 2, 3, 4. That's 8 pairs, 16 electrons. Are all the octets satisfied? Yeah. Again, count oxygen has the 2 lone pairs and the 2 bonding pairs. That's 8 electrons. Carbon has 4 bonding pairs. That's 8 electrons. Oxygen on the right, 2 lone pairs, 2 bonding pairs. That's 8 electrons. So again, the Lewis model, a couple things to keep in mind. We only use valence electrons. It's only valence electrons involved in bonding. That makes sense. Those inner core electrons are held too tightly to the bonded or attracted to the nucleus too strongly. They're not going to be involved in bonding. Only the outermost electrons are. And the other thing to keep on, it's electron pair model, so we're always placing electrons in twos, either lone pairs or bonding pairs. And it's all based on the octet rule. We want to, if we can, satisfy the octet for each atom in that structure, 8 electrons. Of course, hydrogen is an exception. Hydrogen can only hold 2. All right, first video for Lewis structures. There will be more. Have a wonderful day. Take care.